Hi, welcome to Cybersecure channel. Continuing with CKS exam essential, the exam outline broadly divided into 6 domains is flashed on the screen. In today's video, we will continue the 6th domain, which is monitoring, logging, and runtime security, having 20% weightage as per September 2024 format. Today, we will cover ensuring immutability of the container at runtime. Now just imagine deploying a container and knowing with absolute certainty that attacker cannot tamper with its file system at runtime. That's the power of immutability in Kubernetes, a key concept for the certified Kubernetes Security Specialist exam and real-world security. Today we will break down how immutability works, why it matters, and how to implement it. Let's dive in. Immutable containers are like sealed vaults. Their file system cannot be modified after deployment. Here's why this is a game changer for security. It provides security, it prevents malware from injecting scripts or backdoors into running container. It provides consistency. No more it works on my system only. Every instance behaves identically. It provides auditability, which is the predictable behavior, making detecting anomalies easier. It provides reproducibility, which eliminates configuration drift between the environment. Now, how to implement and enforce immutability? Let's dive in. First of all, read-only root file system. It blocks all writes to the root directory, stopping attacker from modifying system files. Then is block privilege escalation. It prevents container from gaining root privileges, which is a favorite trick for malware. Then is non-root user. Even if the attacker gets in, they'll hit a permission wall through this feature. Then is ephemeral storage for temporary files. If you need a temporary space, use empty directory. It's wiped out when the pod dies, leaving no traces at all. Now let's move into the live demonstration. Let's first create a pod with Nginx image and implement some immutability features. Let's have a dry run first. And then in the YAML file, let's implement some immutability feature. Starting from the read-only root file system, and then configuring disallow privilege escalation. And now read-only root file system is being made true, and the allow privilege escalation is made false. Let's now create a pod with this configuration. Let's see if the pod has been created. Now you can see that the pod is not being created. Let's see the logs. The log says that the pod needs to have access of var cache directory, but we have configured all the directory as read-only. Let's make an exemption for this particular directory so that the pod can be created. Let's provide an ephemeral storage to the container by mounting a volume. As we already saw that the pod needed the access to the var cache directory. So we will provide an ephemeral storage space for var cache in Nginx. which is configured through an empty directory mount. I'm doing the configuration manually, but you can always copy the volume configuration from the Kubernetes documentation, which is available in the exam. Now let's create the pod again. I made an error. Let's correct the error. Yeah, the space was missing. Now let's see if the pod is created. Again, the pod is not created, and we are seeing an error. Let's see the logs again. Now, as you can see, that the pod is asking for var/run directory access. Let's create an ephemeral storage for this particular directory as well. Now, after the configuration of the ephemeral storage, we will again see if we are able to create the pod. Now checking the pod creation. As you can see, now we have created the pod, which is an immutable pod. Now, as you can see that we haven't configured the Nginx version. Let's give the exact version to the Nginx image, which is rather a very good security practice. And now again creating the pod. As you can see, now the pod is being created with the exact version that we defined for Nginx. And this container is an immutable container. Let us see the version in the JSON. Yes, the version is the same as we configured. We configured the exact version so that no changes are made to the container when we have an update of the Nginx image. As we can see that an immutable container is now created with best security practice. Now let's recap. First of all, what was the immutability? Immutability means no runtime file system changes. We should combine the read-only root file system with run as known root for defense in depth security procedures. And we must also disallow privilege escalation and use ephemeral storage for safe and temporary storage. In the end, now I would love to hear from you how you implemented the immutability and what problem you face, so that we may resolve them together. Drop a comment, and if this helped, subscribe and share. Thank you.